Alright, so you just learned what perceptron is. The introduction to our first artificial neural network. In fact, introduction to our first artificial neuron, that is perceptron. Alright, so here what I have drawn a shallow neural network. Okay, so this is kind of basic version of deep neural network. Okay, why we call it shallow, I will explain it later. Before that, to explain the term that neurons, artificial neurons, are logically arranged to solve complex real-life challenges. Okay, all these individual circuits are basically individual neurons, artificial neurons, similar to perceptron. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these are artificial neurons. Okay, in fact, this one is also artificial neuron. So this is the diagram of neural network. The first layer, these are called layers, layer 1, layer 2, layer 3, layer 4 and layer 5. Okay, this first layer contains 1, 2, 3, 4, basically this is called input layer. We have 4 inputs. This is X, 1, 2, 3, 4. These are the 4 input values we're getting. Okay, now we have 1, 2, 3, 4, 4 neurons in our first, basically second layer. The layers between input layer and output layer are called hidden layer. Okay, hidden layer. So we have 3 hidden layers here. Each layer contains, the first 2 hidden layer contains 4 neurons, and the third hidden layer contains 2 neurons. Alright, so here you can see the input 1 is getting sent to all 4 neurons in the first hidden layer. Okay, the output from the first neurons in the first hidden layer is being sent to all 4 neurons to the second hidden layer, or maybe third layers, from if you talk about from whole neural network point of view. So here one interesting thing you can see, all the neurons are connected to each and every neurons in the next layer. Okay, in deep learning term or in neural network term, this is called dense network or fully connected layer. In fact, fully connected neuron also you can term, where each and every neurons are connected to all the neurons in the next layers, or in fact previous layers also. Alright, so here something I have written in red, drawn in red basically, these are called biases. Okay, these are not related to, so you can recall the term theta we had in our perceptron, where this particular term was introduced. Those are kind of similar to biases. Okay. Alright. So these individual neurons are arranged in such a way so that the output will be the optimum, will have the minimum possible errors. Okay, our target is to pass some input and get the output as per in our desired format. Okay, so this is majorly a supervised learning methods, and we have some sort of kind of encoding or unsupervised or semi-supervised kind of algorithm also, but that is what we are not going to discuss as part of this lesson. Okay, so as a part of these neural network implementations, if you try to understand broader expectation, like what we are expecting from this, we are going to have some input from this layer, we are going to have some output from here. Now our target is to reduce the amount of error from this whole calculations, and we'll keep training those networks. Okay, how it will work, we'll put something here and it will do all these calculations, multiplications, then activation functions like ReLU, tanh, or sigmoid, or unit step function, whatever suits you as per your requirement, and it will produce some final output. Assume this is classification model where we need to predict the output whether it is belonging to a particular class or not. Okay, and regressions sort of things will produce some values, kind of continuous value. Then we will check how much error we have, how much incorrect predictions we had as a part of our first training. Then we'll adjust the kind of related biases and weights, and these neurons will be updated gradually with the kind of very minimum amount, and it will come in the backward side. Okay. Then again we'll take the same inputs and we'll do the multiplications, we'll try to produce the final output. Again we'll see how much error we have done, and we will send the errors backward so that these weights and biases will be adjusted in small amount, and will reach toward backward side. Alright. So this is something called backward propagation. Okay, so maybe in our later sessions I will explain it how it is exactly working with the mathematical terms inside. For now, your understanding point of view, there is something called backward propagations which is used here to learn the weights and biases for each and every layers. Our final target is to optimize the weights and biases in such a way so that we'll have the minimum amount of errors. Okay, so minimum amount of errors for a kind of generic model. Alright, so this is how it is working. Now, what these individual neurons will understand after this training process. So basically they are going to learn a particular way of representations of this data. Okay, so initially the first set of hidden layers will understand the very simple term like dots, and then straight line with 3-4 characters, 3-4 basically pixels in different directions. Like this is, for example, like what kind of representations they're going to learn. Okay, assume these layers of neurons will learn something like, okay, these one, something like these, okay, something like these, okay, something like these, and similar sort of things. Okay, if you assume in a image recognition point of view. Alright, so different sort of shapes it will try to understand. If you go deeper through this network, like later, and this set of networks will combine these two things and will try to understand more complex representation of the data. Okay, for example, this is named of these layers, or this particular network is learning. Okay, something like that. Just for example, okay, this is combining all these three sort of things, 1, 2, 3. Okay, and it is trying to understand this particular shape. Okay, later it will understand more complex sort of things. Okay, and this way it will produce the final output. Each and every individual neurons are responsible to learn a particular pattern, and often we will not have any control like what we want to train those networks on, like what they're going to learn. So that's why sometimes these methods or this process is called abstract representation learning. They will run definitely to understand a particular representations, but we don't know which representations they're going to learn as a part of that thing. Okay, so if you train it without any kind of particular seed for 10 times, you will see like every time one particular neuron is learning one different kind of representations altogether. Alright, so this is basic thing, and I will kind of try to give some more brief example like what these representations learnings are, maybe in some sort of add-on videos, but this is pretty much as of now you can see like. Okay, so I hope this section is clear. Okay, so alright. So anything else I'm missing here? Okay, pretty much we have covered. Couple of things I need to add related to the introduction. First is that the deepness of this network is known as per the number of hidden layers it has. Like here we have H1, H2 and H3. Three hidden layers are there. Basically, three hidden layers are there. And this is 3 is considered to be a very shallow network. And 3 hidden layers contains 4 and 2 different kind of individual neurons. In real life challenges, you will see sometimes 50, 60 and hundreds and 200s different kind of hidden layers are there. And each and every layers may contain thousands, maybe kind of multiple thousands of individual artificial neurons. Okay. So the deepness of this network is known by the number of hidden layers it has. So this is 3, this is shallow. When you are crossing more than 50, it is a deep network. And later in this class, you are going to implement your own very deep neural network. Alright. So this is pretty much the brief introductions, like how deep learning works and what is deep learning. Okay, so if you have any questions, like, you can let me know, and or maybe later you can connect with me to understand the context, or if you have any doubts, I will definitely clarify those details. Okay. All right. So next section, we are going to discuss about how deep learning works. Like, pretty much we have explained how it works. So I will separately explain it. Again, this would be very base, and I'm not going to the backward propagation as of now. I will discuss about backward propagations when we are talking about the base neural network components later. Okay.